Welcome to the last session of the morning. We are going to have Alper. Not going to say the surname. Sorry, Alper. It's going to be complicated. Ebicoglu. Sorry for that. Alper is the co-founder of Bolosoft, and also he's develops an open source framework for .NET developers. He's one of the core maintainers. So welcome, Alper, on stage. I'm sorry again for the surname. I'm not so good in
It's
surnames
impossible.
internationally.
Impossible to
Yeah,
say everyone's surname in different languages.
languages. Yeah, how it's pronounced. Sorry, you can say it.
Ebicoglu.
Ebicoglu. Okay,
Ebicoglu.
perfect.
Yes,
Okay, I'm
it's
gonna
hard.
I'm gonna try next time. I'm gonna
There
try
is
next time.
Turkish C in my
Yeah,
surname, which is not available in other languages.
yeah. I can imagine on that. Okay, perfect. Okay,
Okay.
I'm gonna put the slides on stage so you can start the presentation. And for everyone, feel free to ask your questions on the chat window. Alper, the floor
Thank you.
is yours.
It's my turn. Hello, everyone, ladies and gentlemen. Thank you for joining me today. My name is Alper, and I'm one of the co-founders of Volosoft. And this company is empowering .NET developers by creating frameworks and simplifying the complexities of software development. And we are trying to allow focus on your business. So one of our flagship project is the ABP Framework. This is a open source, powerful application framework, and it implements many cross-cutting concerns of a web application. Today, I'm going to share my experiences and insights that I have gained while implementing major multi-tenancy requirements. This is my first open source project, and in this one, we have started in 2013. It's called ASP.NET Boilerplate. This repository has more than 11K stars on GitHub, and we have released 200 versions. It's one of our first multi-tenancy framework. Then we have rewritten this legacy framework to be fully modular and multi-tenant and microservice compatible. This one is called ABP IO, ABP Framework. So we have released more than 200 versions so far and 12K stars on GitHub and 20 million downloads on Nugget until now. So why I'm showing you this? Because we have experience a modular application development and we have a good experience on microservice architecture, DDD. And in the next slides, I will show you how we solved some real-world multi-tenancy issues and how we cover them. So ASP.NET Core is a generic web application framework, and many of us using this to build some HR, CRM, or other ERP applications. So generic web framework, this ASP.NET Core, provides us essential features like routing, dependency injection, request response handling, security issues. And on top of the ASP.NET Core, there is ABP Framework, and it's an opinionated architecture. It focuses on to build a line of business applications, and it's trying to implement cross-cutting concerns of a business application like exception handling, caching, localization, validation, transaction management, social login, something like this, and also multi-tenancy. And in the final layer, you can focus on your business and no need to deal with multi-tenancy, because I'm always saying these cross-cutting concerns should be implemented in a core library or in a framework level. Today's agenda is starting with introduction part, and later I will talk you about advantages and disadvantages of multi-tenancy. Later, I will show you some different scenarios of application and database deployments. And sometimes you need to change the active tenant. But first, we need to identify the active tenant. So which tenant is this tenant that this request coming from? And also, data isolation is another issue of multi-tenancy. How can we separate the different tenants' data in virtually or physically. Later, we may need to conditionally turn off or turn on multi-tenancy for some cumulative reports or other things, background jobs. I'm going to show you how to do this in code. And handling database migrations is also another issue if you have a tiered application and different environments, geolocations. And finally, if we have time, I will tell you a little bit how we implemented our feature system. So multi-tenancy is an architectural approach. It's nothing to do with ASP.NET Core. In all language or platforms, you can create your own multi-tenant applications. It's for building SaaS applications, software as a service platforms. And in this approach, hardware and software resources are shared between your tenants. And tenants' data and configurations are logically or physically separated. And in this terminology, there is tenant and host. Tenants are our customers, clients who are using the system, and host, you, the solution owner, the service provider. And bear in mind that multi-tenancy system should be designed to work seamlessly and make your application code multi-tenancy unaware as much as possible. You shouldn't pass tenant ID to all your URL parameters, controllers, application services, repositories, domain services. It will be also open to human mistakes if you pass this tenant ID to all these layers. Also, do all tenancy-related stuff in a low-level layer and keep your business code clean as much as possible. And when your customer wants you to deploy this application on their environment, you should be able to deploy it on-premise as well. So don't stick to any cloud service or any maybe your custom environment. It should be also deployable to customers' environment. There are different service models, SaaS service models. The first one is on-premises, which is not SaaS-friendly. You need to deal with all kinds of different stuffs like networking, electricity, Windows updates, database management. Everything is under your control. It's called on-premise. You install it to your customer's environment or to your environment, and you will deal with everything. The second one, there are some different options, virtualization, servers, storage, networking. These are maintained by the third party who are, which you already getting service. And for this model, Google Compute Engine is an example. Azure Virtual Machines is an example. So you are using the infrastructure. Sometimes you may need it if you are running custom executables or need to do some custom things in operating system. You may need this environment. Also, there is another model, PaaS, Platform as a Service. In this model, you only deal with your application and database. Other things are managed by the third party. For example, Azure App Service, Heroku, Google App Engine. These are examples. And lastly, the real software as a service model, you will not deal with all platform or infrastructure level things. All these are maintained by the service provider. Like Discord, Zoom, Gmail, Netflix, these are SaaS services. So there are advantages. There are many advantages of multi-tenancy, but I will count most 5 important of them. First of all, it's cost efficient. What I mean, you share the hardware and software among your customers, and you reduce costs and serve the maximum number of customers, so you maximize the utilization. And secondly, you will have a consistent user experience because all your customers are using the latest version, and we as developers can focus on maintaining a single code base, ensuring that all tenants receive updates and improvements at the same time. And third one, ease of maintenance. So maintaining a single code base and infrastructure for all tenants simplifies our software updates, patches, bug fixes, and also it reduces the complexity of managing multiple instances, making it easier for our life to maintain the system. And scalability is also another one. When there are demand spikes, you can easily increase system resources. Like when there is a Black Friday season, you can add more instance of your application behind your load balancers easily. But imagine that if it was an on-premise system, it will be very hard to set up new environment to scale up your system. And also, deployment is very easy for new users. Because whenever a new tenant onboards, it is just a new line of database table record, and that's it. He will be using the system in the same time. No need to set up anything for your new client. I'm going to show you real life code that we implemented in the framework. These are description parts, metadata, and boring part. And there are some challenges of creating a multi-tenancy application, actually. First of all, we are isolating data, maybe in the same database, or we physically separate their databases. And you need to ensure proper data isolation between your tenants to prevent unauthorized access to sensitive information. If you cannot do this, or imagine that a junior developer joins the team and he forgets some tenant ID in a query, what happens? Everyone, all your tenants will see everyone's data. So you need to do this in a framework level, and you need to guarantee the tenant ID will be added to all queries as a filter. And your clients sometimes request you to customize the application according to their requirements, because they will have their own branding colors, UI logo. They will want to change the color schema, and maybe they will have different retention policies. So it will be hard to develop an application for different tenants to be fully customizable without compromising the core architecture. So we cannot write, if customer is Nike, change this, or so. You need to allow customers to change customization options from a UI. Also, there is a performance balance problem. Some customers may use the system extensively. So we call these guys noisy neighbors in a multi-tenant environment. And these can consume too much resources. And we should ensure that the resource usage of one tenant doesn't affect negatively the performance of another. So this should be done by monitoring the system, and you may need some extra DevOps tools for this one. Security is a crucial option in this one. When a hacker gets into your server, he can steal all your tenants' data. Also, if you have a security hole, a tenant gains access to other tenants' data. So you need to ensure that you cover all WASP security problems, issues. It's another challenge. And also, backup recovery is another thing. This involves database and storage backup per tenant. It will be very easy to backup restore when you have a separate DB for each tenant, But if you have a shared DB, then you need to get backup of a specific tenant. You need to gather information from different database tables, and it should be restorable. Also, your customers may have different retention policies, so you need to implement different strategies for each tenant, for maybe government agencies and banks. This is different database and deployment architecture scenarios. In the first one, it's on-premise style deployment, not SaaS friendly. You deploy your application instance and database for each your tenant. It's not very SaaS friendly. In the second one, you share your application instance with among all your customers, but each of your customers will have separate database. This is good, but not good for resource utilization. And it's also hard when you have update your application instance. Maybe your database schema is also needs to be updated. You cannot update everyone's database at the same time. But when you update your application server, it will check other databases, and if one of the tenants' database is not upgraded, they will get exceptions. Also, you need to figure out how to deploy these databases in the second model. In the third one, this is SaaS friendly, maximum utilization. Customers will share the same application, and they will share the same database, but it will not be very feasible because they will ask to separate their DB, like banks. Banks will not accept to be in the same shared database, or government agencies. They sometimes tell for the GDPR rules, they need to locate their database in their country. So the fourth one, hybrid model, covers all these requirements. If a customer pays more, you can separate their database, and if not, they can be in the same database. So we web developers know that HTTP is a stateless protocol. What does stateless protocol means? User data is not persisted from one page to the next. And our web application, multi-tenant web application, should also be stateless. And the tenant ID shouldn't be stored on the server. Because when you store it on the server, you cannot scale up. There will be different servers. One customer logins in one web server, you store their tenant ID. The other servers don't know their tenant ID, and the next request may go to the other server, which doesn't know the tenant ID. So this is not good, friend. Also, stateless approach is multi-thread friendly. Then where should we save the state? We can save in HTTP requests, cookie, or header, or query string, or payload of the request. Also, you can save the tenant ID, in authentication tickets as GVT, or in DB, or in distributed cache, like Redis Memcache. These are all good options to save tenant ID. Okay, up to now, I gave you general information about multi-tenancy. Now let's see some code and real-world solution. I gathered some code from ABP Framework, and these code are simplified versions of the real code, because I want to focus and make you understand easily what's going on in the code section that I will highlight. So when a user makes a request to the application, you need to understand which tenant's user is this user. There are 6 ways of finding the current tenant, active current tenant, in our implementation. And these 6 are all fallback of the previous one. So we will first look to current user. Let's see how to do this. So claims. When a user logs into the system, we can save his tenant ID to the claims. And when the user comes back again, we can identify the user from the claims. And it's very easy in ASP.NET Core. In the framework, we are using a current user object here, iCurrentUser. And the current user.tenant ID is just HTTP contexts user identity claims collection, and we are filtering tenant here. If you cannot find in the claims, then you can search in query string. Yes, also query string is another way of storing tenant ID. Here you see tenant ID is 3, or you can write the tenancy code like tenant is Adidas. And you can get it from HTTP context request query object. And next, if you didn't find it, URL parameters, you can use routing. Here, ACME is a part of our URL, and we can easily get this route value from HTTP context get route value method. And if you find this, retrieve this tenant ID. If you still cannot find, let's go fall back to the next one. We can get the tenant ID from request header. Here, our application sends the tenant ID itself. It's a GUID here. And we can easily get the tenant ID from HTTP context request headers collection. And it's good for single page applications, also third-party clients like mobile apps. You didn't find in header, then you can jump to cookie. Cookie is also a good place to store your tenant IDs. Here, I'm sending tenant ID in my request cookies. And in my server code, I can read it from HTTP context request cookies collection. And lastly, if you didn't find all these from all these places, you can use subdomains. It's also a good one, especially if you are making an e-commerce online shopping website. You can use the subdomain here, like adidas.sports.com, nike.sports.com. You can read this value by getting request host value, and you may need to write just a simple regular expression parse method. I didn't write the inside content of the parse, but you can easily get this part, and you can use this as your tenant name, and you can set the active tenant from this part. Okay, we see how to identify the active tenant. Let's understand how can we isolate the data. Actually, there are two ways, logically or physically. Let's see the traditional way. When you have a repository, this entity is books entity. This is how you normally do this. You filter the tenant ID. You get the active tenant from my previous slides, the current tenant, and current tenant ID equals to my tenant ID in my repository table. But it's open to human mistakes because you can forget this. I'm going to show you how to make it automatically parsed in a framework level. So we are creating a iMultitenant interface, and in this interface we have a GUID, nullable GUID tenant ID. So we are standardized. We are making standard the tenant ID field. So in the following slides, I will show you how I will parse or how I will set this ID programmatically in my application. So to filter a tenant ID in your application globally, there is very good feature of Microsoft Entity Framework Core. It's called Global Query Filters. And this is good for filtering. It's a filter condition automatically applied to all the queries for a given entity. So it's good for soft delete, multi-tenancy, or if it's a bookstore application, published field, you can use this. It's a link queue expression that applies to entities on model creating phase. So you do like this in your DB context. On model creating phase, you write has query filter, and it will automatically add all your queries in your repository. But let's see how can we make it automatically filtered in our application. So in the framework, we are checking this is again in DB context, and we create our own DB context, inheriting DB, the original EF course. So we check if our entity is an multi-tenant entity. If yes, we are creating a new link queue expression. We get the current tenant ID from active scope and create a new expression here. And we are using has query filter of EF core and adding it globally. So you will not miss this one in all your queries. It will be automatically add in the framework level like this. So you need to just add multi-tenant to your entity, and that's it. It will be globally filtered by tenant ID. This is good, easy to implement, supports navigation properties, but works only with EF core. And it also has some drawbacks, because when you want to disable a query, you cannot. There is an option to disable filters, but it filters all the filters, like multi-tenancy, soft delete, everything. Also, if you are planning to inherit an object from animal, like big animal, small animal, you can define this only to animal entity. So global query filters work on the root entity. Also, if you want to use stored procedures or raw SQL queries, it's not supporting. These are ignored in EF Core's global query filters. But there is a good news for this one. You can use Microsoft, if you are using SQL Server or Azure SQL database, you can use row level security. In this option, all the tenant ID is filtered automatically in the database level. So even if you open the SQL Management Studio and write your own TSQL, it will be filtered for the tenant, because it depends on the connection string. But again, you are stuck with the SQL server. If you want to change it later, you need to build all these multi-tenancy features again. So for me, pragmatic solution is EF Core's global query filters. Also, if you are not using EF Core, let's say we are creating an application on top of MongoDB, DocumentDB. It doesn't have this option like EF Core, no global query filters. So in this kind of scenario, you can create your own global query filter. How can you do this? So you will again use multi-tenant interface to check if your entity is multi-tenant or not. You will create your own expression, tenancy filtering expression, and then you need to add it to your custom global query filters, and you need to use your MongoDB repositories to filter this. So it's a workaround of how to make custom global filters for MongoDB. We see these options, how to identify the active tenant and isolate the data. Let's see how to set the tenant ID. Actually, when you create a new entity, you can set it manually, but again, it will be open to human mistakes. You can easily forget to set tenant ID. So I am suggesting you to create your base entity class, which can be abstract. And in the protected entity constructor, you can check if it is a multi-tenant entity. If yes, by the help of reflection, and you know that you have tenant ID, it's standard. We make it standard with this interface. You can set the tenant ID. You can get it from the current scope like this and set whenever a new entity is created. So again, in the framework level or your core library, this will be automatically done, creating a new tenant. So you will not forget any tenant's ID setting. Let's see how to select the connection string, because when you have shared database, okay, it's not problem. But when your customers have separate databases, what will you do? So in my framework, we are doing this in a database table. So we have a app settings JSON file. In this app settings JSON file, we have master DB connection. This is stored in the app settings JSON. And when the application gets a new request from a tenant, we first check this table. If this customer has a custom connection string here, because here tenant ID and connection string value stored here, then we are using this connection string to start up the DB context of this customer. Also, you can do this for any custom microservice. So when a new microservice boots up, you can check its database connection string. If it's here, then you can use. If not, you can use the default connection string, which is shared. I'm going to show you how to do this in code. So here we have default connection string resolver. This is a framework base class, and we are creating our own multi-tenant connection string resolver. So we know the current tenant ID from the previous slides, and we check the database. You can make caching here, so not every time you go to the database. I deleted these parts because to focus you here. And we see this tenant has a dedicated DB, and we are resolving their connection string here, and we are using Microsoft's DB context creation options approach. DB context creation options allow you to set connection string each time when a DB context is being created. So every customer, every tenant can have dedicated DB, or they can share the same DB if we implement this. So until now, we identify tenant, we isolate data, we set the tenant ID for new entities automatically, we select the proper connection string for the customer. Now it's time to change the active tenant. Why we need to change this active tenant? In each HTTP request, you can only query for the active tenant. It may be necessary to change the active tenant, for example, when you have a background job that generates reports for each tenant. You need to iterate through your tenants, and you need to change this tenant every time you switch to other tenant to create reports or cumulative data. So how we do this? This is how the developer use this. Current tenant change, and they provide tenant ID, and inside this using block, all the queries will be filtered by this new tenant ID. Even this tenant, the active tenant, is a different one. So it's an disposable method. You see the implementation here. We store the current tenant in a temporary variable, and here we are creating a basic tenant with only name and ID. And whenever the code run finishes, we revert back to the original tenant we stored here with the dispose action, so that we don't forget to change back to the original tenant every time we change it. So you see here, I'm also using current tenant change. This is the main multi-tenancy filtering middleware. This is the startup file of my application. And I'm looking to one field, one flag, multi-tenancy enabled. If it's enabled in my application wide, then I'm using this middleware and changing tenant. For disabling multi-tenancy, we have another option. We are using a singleton dependency here. We have concurrent dictionary that all the filters are in this dictionary. And when we disable this, we first check here is if my multi-tenancy filter is enabled, because I'm getting multi-tenant filtering from this object. And if it's enabled, I'm using EF Core's global query filters. If not, I'm not using it here. Okay, I'm going a little bit faster to explain. I have no time, I think. I will explain you different database migrations. Approach 1 and approach 2, I'm not suggesting these options for high scale options. You can create a custom tool, update all the databases, but it's time consuming. You cannot update everyone's database. Also, in the second approach, when a tenant makes a DB interaction, you can trigger their database migration, but it's also not good for the first user. He will get timeout exceptions and concurrency problems. And this is the suggested way. Sometimes, okay, in the old version, left side in the graphic, you see we have our legacy application, and in the new platform, we have the updated version. Our application server is updated and database schema is updated. So when a user comes to our system, we first check if his system is updated. If not, we route it to the old version. If yes, you route your customer to the new application server. By doing so, you will wait your customers in a minimum time. Also, you can schedule upgradings for your tenants. You can run A/B tests and see bugs before new customers or any other big customers. So this is good, and this is how Google updates their Gmail in the old times. So in the old times, I see Gmail updated the UI. I was experiencing the old version, but my friends already using the new version because their application and DB is updated, and Google routes these people to the new environment. And I got an email that's saying my UI will be updated in the next following weeks, and I will experience the new platform. So this is the ideal way for big systems. If we have time, I can explain you feature system. So feature system is when you create a subscription-based platform, you will have different plans and you will have different features. Here you see Netflix HD available option. It's not available in basic and standard premium they offer. How we do this? Microsoft Solution Feature System Nugget package. When you search internet, you will see first this one, but it's not good. It's not for feature management system. This is for Azure A/B testing. It doesn't support multi-tenancy as well, and it only supports Boolean values. So you can create your own feature system. Here, feature definition provider, this is my custom class here, and features are stored in my read-only list. And whenever a method runs, I can add an attribute here, requires feature, and I can intercept the method and check is HT available option is available for this tenant. Also, you can make inline checks, conditional checks like this in your method. So it works in any class that is injected from dependency injection. So just create an iFeature checker interface and inject the methods like this, or allow developers to query this feature conditionally. And you can easily render these features that's stored in your read-only list here on a UI. So you can create your own subscription plans and different editions. So this is all from my side. Thank you for listening to me. If you are interested in these options and how we built this, I showed you a little limited features to make this presentation in time. You can go to ABP.io. It's open source, free. You can check. If you want to download this presentation, you can download it from my GitHub presentations repository. And I think we finished our time, 5 minutes.
Yes, well, we have a couple of minutes left, just in case that we have some questions from the people, but nothing appear at the moment, so I will give a couple of a minute, something like that. Thanks, Alper, for your presentation. Actually,
do you have any
cool.
questions? I think
yes, I removed myself accidentally.
yes,
Sorry,
we didn't hear you.
yeah. I have many questions, but I think that we don't have too much time. Good to see that .NET, it's well, Microsoft in the end, it's also investing in open source technologies and frameworks. So that's something cool to see, at least from my side, knowing Microsoft for a long time. So yeah, it's cool to see that. Aside that you call for action, where else we can collaborate with this project, Alper, in the GitHub, or going to
yes,
to
this is
Twitter?
as you see on the screen, https abp.io on the right side here. This is the website, and when you go there, you can find the repository link. You can check out. It's also good for DDD, also microservice features. You can check and understand how we implement this, because there are many contributors in this framework who make this framework consistent and rock solid. It's also good source for educational checking.
Cool. Okay, cool. Thanks a lot, Alper. I don't see questions on the chat, so we can finish the session for today. Thanks a lot for being with us, having this talk with showing what you are doing and your project. For the people still watching, we will have a lunch break after this talk. We will return at, let me check, because before I say the time a little bit wrong, mainly because I have two different windows and tabs that says obviously one the local time and then my local time. So at 1:40 p.m. European Central Time, we are going to return with what the F commit messages by Andrei Solznev, and for the people that are watching from the GM3 plus 3. You are watching from Lithuania, you're watching from any other Baltic area, it's 2:40 p.m. So we will see in about 1 hour from now. Thanks a lot and see you soon. Thanks, Alper.
Bye, everyone.
Nice day.
Have a great
Bye.
conference.